students, in this part we will study about the compounds formed from common salt, obtained from common salt. Now what is common salt? This is sodium chloride. Sodium chloride, that is NaCl. Now we have studied in the previous part, in the first part, that NaCl is a normal salt and has a pH of 7 because it is formed by neutralization between NaOH and HCl. NaOH is a strong alkali and HCl is a strong acid. So when neutralization takes place between them, then NaCl is formed and it will have pH of 7. That is, it does not undergo hydrolysis. So it is formed by neutralization reaction between NaOH, sodium hydroxide, and HCl. Now it forms neutral solution. Neutral solution means its pH will be equals to 7 because it is formed from a strong base alkali and a strong acid, that is hydrochloric acid. Common salt NaCl is an important compound, important chemical used in our daily life. It is the ingredient of our food. Now it has importance in our biological process also. Now common salt is obtained generally from seawater. Seawater contains different types of salts, different types of compounds dissolved in it. Now at the coast of the oceans, the seawater is filled in tanks at the bank, at the platforms, where it evaporates and the salts are left behind. This salt is then sent to the factories where after recrystallization process it is purified and we use it in packaged form, which is white crystalline solid, that is a common salt. So it is obtained from seawater. It is obtained from seawater. So first of all, seawater is evaporated, the salts are left, which will contain different other compounds also, salts also. So in factories, after recrystallization process, we obtain pure sodium chloride. Now sodium chloride, that is the common salt, is also obtained from the earth crust and then it is known as rock salt. It is mined from the earth crust, like similar to coal mines. Now the rock salt is obtained from mines in the earth crust. Now you see, the rock salt contains, that is, it is colored, that may be brownish, that may be blackish, and so colored due to the impurities of salts of other metals. So rock salt is obtained from mines in the earth crust. Now, and how it was formed? So it was formed when in very ancient time, bygone age, when the sea dried up then the salts present in seawater got sedimented and then a layer of earth crust was formed over it. So rock salt is now get trapped in the earth crust. Clear, student? Now, common salt played an important role in our freedom, the freedom movement of India also. You have often heard about the famous Mahatma Gandhi's Dandi March. This is to violate the rule made by the British government by preparing the salt by ourselves. So now you have seen that is the famous Mahatma Gandhi Dandi March. Dandi March related to common salt. Related to common salt, that is NaCl, played an important role in Indian freedom movement. Indian freedom movement. So we can say that the common salt played an important role in Indian freedom movement. So just we have studied that is it was this movement launched by Mahatma Gandhi, used by Mahatma Gandhi, was to violate the British rule and to make the Indian people together to disobey that law. So we have studied about the common salt. Now, common salt is used to obtain various type of compound, important compound used in our daily life. Now, the compounds like sodium hydroxide, baking soda, washing soda, soap, detergents, bleaches are produced from common salt. So we have to study here the chemicals obtained from common salt. That is how we'll get how is the importance of important common salt for us in daily life. As a common salt, it is the ingredient of our food, and now in chemical, in industry, in laboratory, it also plays an important role. So first of all, we study here sodium hydroxide. Sodium hydroxide is prepared in industries from common salt. How is it useful to us? This is prepared, it is obtained by electrolysis of brine solution. Now what is brine solution? We see here that is it is the concentrated aqueous solution of NaCl. It is obtained by the electrolysis of brine solution, that is concentrated aqueous solution of sodium chloride. Now suppose we take here the simple arrangement of this electrolysis process. Suppose we take the two rods electrodes. Now connect the circuit with the help of battery. Now this is cathode, this is anode, and here this is NaCl solution, concentrated NaCl solution. So when NaCl is dissociated, it gives Na plus and Cl minus. At the same time, water is also ionized and gives us H plus and OH minus ions. Now, at the cathode, due to higher concentration, chloride ion is discharged, at anode, chloride ion is discharged giving Cl, and Cl being a diatomic gas, it gives Cl2. So at anode chlorine gas is obtained. In similar way, at cathode H plus ion is discharged. H plus H gives H2. So at cathode hydrogen gas is released, but now you see that the Na plus, here you see that Na plus and OH minus together remaining in the aqueous solution will make NaOH. So Na plus and OH minus together makes NaOH, means the solution in the electrolyte will be left with NaOH. So what are the products in the electrolysis of brine solution? There are three products. Now this process is especially known as Chlor-alkali process. Chlor-alkali process means the electrolysis of aqueous solution or brine solution producing chlorine and NaOH. Chlor for chlorine and alkali for NaOH. Hence, this is especially known as chlor-alkali process. Now, so we write here, students, that what are the different products of this process, that is chlor-alkali process. Now, there are three types of products, a student. You write here again, products: hydrogen, chlorine and NaOH. Now, how is the hydrogen useful to us? Hydrogen is used as fuel. It is used as rocket fuel. Now, for making ammonia, that is NH3, margarine and fertilizers. So hydrogen is used for these three processes, or that is there are many other, like it is also used as reducing agent in industries. Now chlorine is used as bleaching agent, in swimming pool, for disinfecting, for making PVC, CFC, etc. That is, it is used for many other processes also. Now, NaOH, sodium hydroxide, like first of all, for degreasing of metallic articles, cloths, etc., soap, detergents, paper, borax, bleaches, etc. Now, similarly, you will also use this compound, bleaches, washing soda, baking soda, etc. Now, further you see, a student, that these two can be used for making HCl, that is hydrochloric acid. Similarly, these two can be used also for making bleaching agents. So these were the different compounds, different products obtained by during preparation of sodium hydroxide, that is in chlor-alkali process. Clear, student? Students, we have already studied that by electrolysis of brine solution, the products formed were sodium hydroxide, hydrogen and chlorine. Now we have to study the other compounds obtained from common salt and from the product of common salt. It is the bleaching powder. As the name suggests, bleach means decolorizing, means this substance is used for decolorizing purpose. Now, bleaching powder is prepared in industry by passing dry chlorine gas over slaked lime. What is slaked lime? Slaked lime is dry calcium hydroxide. Calcium hydroxide is used under the three names. One is lime water, that is the saturated aqueous solution of calcium hydroxide. Calcium hydroxide is sparingly soluble in water, little soluble in water. So when it is mixed with water, then it partly dissolves and excess of it gets sedimented. The upper clear solution is known as the lime water. Next, milk of lime. If the question is asked what is the compound present in milk of lime or lime water, it will be calcium hydroxide. Milk of lime, that is the suspension of calcium hydroxide in water, which is used for whitewashing of walls. And the third, calcium hydroxide in dry state. This is called slaked lime. So, when dry chlorine gas is passed over dry calcium hydroxide, so we must write its name slaked lime because it may be present in the another form, slaked lime. If dry chlorine gas is passed over it in a drum, then you see that it forms calcium CaOCl plus H2O. This is bleaching powder. Bleaching powder. Now, a student, it can also be written as calcium. This one, CaOCl, Cl. The actual formula for calcium bleaching powder is this one. In general, we write like this. This is calcium oxychloride. But in the formation, in the composition, it has three types of ion: Ca2 plus, OCl minus, that is hypochlorite, and then chloride. These three ions are present. Hence, it is also known as calcium chloro hypochlorite. So this is the chemical name of bleaching powder. Now it can also be written as calcium oxychloride or calcium chlorohypochlorite. So in general we write it like this. Clear, student? Now this is the bleaching powder. Now bleaching powder has many uses. Now one more thing, student, suppose bleaching property. You study here bleaching property. Bleaching property. Now this bleaching powder CaOCl2 decomposes to give us CaCl2 plus nascent oxygen, and that will act as a strong oxidizing agent. So bleaching powder, it bleaches by oxidation. This is why it is not used for bleaching the coarse fabrics. Coarse fibers like silk or wool are not bleached by this one, but it is used for bleaching the coarse material like the paper, the cotton. So it bleaches by oxidation. So it is used to bleach wood pulp, paper, cotton, etc. But it is not used for bleaching the coarse, that is a fine fabrics, fine fibers, delicate fibers like silk or wool, because that will be damaged due to a strong oxidation. Now the another use for it is as disinfectant. It is used as disinfectant. Now in swimming pool for killing germs, in purifying water, etc. So we see here it is used for these different properties or processes. Now further, it is used as oxidizing agent. In industries and in laboratories, etc. So these were the different basic uses of bleaching powder. Clear, student? Now in the next part we will study the compound like washing soda, baking soda obtained from common salt or sodium hydroxide. Clear, student?